So the big idea in 6.3 is that we have several different sorts of statistics that we've studied in this class. So means, proportions, variances, standard deviations, medians, modes, mid-ranges, ranges, right? We have a whole bunch of things that we have done. Only 3 of those, our most valuable players, our MVPs, the mean, the variance, the proportion, only 3 of them actually target the population parameter. And so this homework will feel much of a sameness because they'll say, hey, let's do it with variances. And then they'll say, hey, let's do it with medians. And hey, let's do it. And it's a lot of work and you have to put stuff in StatCrunch and some of it. Anyway, let's do a couple and you'll see, oh yeah, they're all exactly the same, aren't they? This one uses StatCrunch and sometimes students aren't sure how it's working. So what we have done is we have 3 households. And you say 3, that's not a very big sample. No, that's not the sample. And you say, well, 3, oh, yeah, this is the population. And you say, population? Yeah, it's a little cul-de-sac and there's 3 houses. That's our population. And you say, 3 houses, are you going to talk to all of them? Oh, no, I'm a statistician. I'm not going to talk to all of them. I'm going to get a sample. And you say, well, if there's only 3 houses, how big is your sample? Well, it has to be at least 2, right? Samples of size 1 aren't very useful. So we'll talk to 2 of the houses and you say, okay, well, what are the houses? Well, there's a house with 3 people living there and there's a house with 5 people living there and there's a house with 10 people living there. Whoa. And we're going to grab samples of size 2 and we'll randomly choose. We will open it up in StatCrunch. And what is this? Okay, so what this is we've numbered the samples. Why did you do that? Just for convenience. But do I use this number? No, it's just for convenience. I kind of think this is a wasted column. I think it confuses students. Well, what's this? Well, this is one of the houses. You know, we had 2 houses in the sample. And what house was it? It was the house that had 3 people. And this tells you there were 3 people. Then we put that house back because the best sampling is with replacement. So we replaced that house and we chose a house at random. Oh, hey, look, it was the same house. Yeah, well, sometimes that'll happen if you sample with replacement. And so we got 3 and 3, we got 3 and 5, we got 3 and 10, we got 5 and 3, 5 and 5, 5 and 10, 10 and 3, 10 and 5, 10 and 10. You kind of notice a pattern here. It's like, oh, you have the 3s, and then you have the 5s, and you have the 10s. You have the 3, the 5, 10, the 3, the 5, the 10, the 3, the 5, the 10. I point out this pattern to you because you'll have patterns like that later where MathLab is not polite enough to list these out for you. And you will have to open up your own StatCrunch window and enter values like this. And they'll follow a pattern like this, where you'll have the first possibility several times, the second possibility several times, the third, the fourth, whatever the number there are, and then each possibility over and over in a list. So kind of notice that pattern. What we are looking at in this particular problem is the variance. And I think, well, I know how to find the variance of each of these samples. Here's a variance. Well, this one I even know because 3, 3, we know that if the values are identical, the variance is 0 because there's no variation at all. But it would be nicer if we could calculate it. So we go to stats, we go to summary stats. How are our data arranged? Well, think about it for a second. They're arranged in rows. Each sample is its own row. So we go to stats, we go to summary stats, we go to rows, and we say, what's this sample? That's just a number. Oh yeah, okay, so I'm not doing that, but I'm doing these 2 columns. So I click and drag. And what am I especially interested in? I'm especially interested in the variance. I'm trying to find the variance. So I click on variance. If I click on compute, I'll go ahead and do it just to show you why you shouldn't. Well, there's a bunch of variances. Yeah, but this is so inconvenient. Well, what's the probability that a variance is 0? Like how many? It's like this is not convenient at all. And then what are we going to do later? You know, the principle of this section is if you have a bunch of variances, what's the sample distribution? Well, I can't do anything. These are in a little box. Well, find the mean. No, they're in a little box. I can't do it. So don't do it that way. What you should do instead is, after you've chosen your columns and chosen variance, make sure you click this little box, store these values in a data table. After you've chosen your columns and chosen the particular statistic that the problem asks you to handle, make sure you check the little box, store in data table. And then when you click compute, what StatCrunch will do is give you a new column, and they called it row variance, and they added it to the data table. And look, there it is, row variance. Oh yeah, there it is. Huh, there's the variance of all those rows. Neat. So what they want you to do is they want you to list, in other words, create a probability distribution of all of these values. They give you a choice of, well, what should you use for S squared? And you say, I don't have any ones, right? I'm looking at these variances. I don't have any ones. I don't have any 3.3s. Oh, I have some zeros. So let's look at the zeros. And what's the probability that one of these is a zero? And you think, it'd be nicer if they were organized. Wouldn't it be nicer if they were sorted? Yes, it would. So there's a little pull down. All you have to do is hover your mouse cursor over this, use the pull down, and say sort table ascending. This is why I looked at the first one, was to see, is it ascending or descending? I think most of the problems in this section are ascending, but I remember one is descending, and it just annoys me that they would switch like that. So look to see. Anyway, these are ascending, and so I click on it, and it fiddles with everything else too. That's all right. We don't care, because all we're looking at now is this. And I say, it looks to me as though there are 9 rows, and I think that 3 of these are zeros. So 3 out of 9, that feels like the probability to me. And we could put in 3 out of 9 if we felt really, really mathy. We could even reduce that fraction and say 1 out of 3, and that feels good. The next one is 2. So a variance value of 2, and there are 2 appearances of 2, and 2 out of 9 doesn't reduce at all. It's 2 out of 9. The next one is 12.5. And again, counting them 1, 2, there are 2 of those, so probability 2 out of 9. We saw it was 9 because we saw the number of rows. Last but not least is this 24.5. There are 2 of those. Is this a probability distribution? Well, we learned about probability distributions before. What we learned was that the random variable must be numeric, and they are, and these things have to add up to 1. And you say, well, 3 out of 9 plus 2 plus 2 plus 2, that's 9 out of 9. It does. And each of these values has to be between 0 and 1. So this is a good probability distribution. What kind? It's not a kind that we know. We don't know the name of this. Well, what's the population variance? Really good question, sir. Yeah, how would you get the population variance? Well, look at the population. It's 3 and 5 and 10. And then what? In the book, didn't we just have a formula for the population variance? Yeah, but I thought it's a thinking class, not a math class. So the easy way to do this, I'm going to list those things over here so that I can let StatCrunch do the work. And because my memory is full of holes, I'm going to click on this heading, and I'm going to write in population so that I know what this is. And then what? I'm going to put in the 3, and I'm pressing enter, and then the 5, and then the 10. And there are my 3 values for the population. And StatCrunch is able to calculate population variances. There's kind of a trick to it. You might remember it. We go to Stat, we go to Summary Stats. How are these data arranged? Well, this population is in a column. It's in a column that's labeled population, and it has 3, 5, and 10. And to find the population variance, they put it way at the end. They call it the unadjusted variance. And why do they say unadjusted? Because if you remember the formula for the variance, it has an n minus 1 in the denominator. And this just has an n, a capital N, because it's a population. So calculating that, we hit compute, and we get 8.6666666. And what do we do with this? Well, the prediction, the thing that we think will happen, is that if you calculated the mean of the sample statistics, the variance of each sample of each row, if you calculate the mean of this, it should be really close to this. That was the prediction. So let's find out. Let's go to Stat, Summary Stats, and These were in a column, right? There's a column of row variances, and we want to calculate the mean of the sample statistic, and we expect to get the population parameter. Why do we expect that? Because this is a variance. It's one of our MVPs, V for variance. And you look at the thing we just calculated. The mean of the row variance is 8.666, and the unadjusted population variance was 8.666. Wow, it's exactly the same. And they will be for our MVPs, for the mean, the variance, the proportion, and they won't be for any of the others. Did the sample variances target the population variance? Yeah, it was dead on. So they do make good estimators because they target. And that'll be true for the M's and the V's and the P's, and not for any of the others. Here's another one. So again, a very small population, and we're going to get very small sample, size 2, and we are going to find the value of the standard deviation, and we think, okay, I kind of know how this is going to go. So let's see if we can do it. We'll open up our data in StatCrunch. We need to find the standard deviation. So again, these two columns are the two values for each sample. They've listed out the samples and then they've keyed them in for us. So we go to Stat, we go to Summary Stats. These samples are listed in rows, of which this sample is just a convenience number to refer to them. These are the two values. We're interested in the standard deviation. We want to store it in the data table. You see how these go faster if you don't have to explain every single step. They added a new column. Nice, there it is. Let's sort this column ascending. They want to know the population standard deviation first. We know how to do that. We create a population column, and then we put in the three values, 3, 4, and 11. So here comes the 3, here comes the 4, here comes the 11. We go up to Stat, we go to Summary Stats. That population list of values is in a column that I conveniently labeled population, so I don't have to remember what it was. And we want to know the population standard deviation. Again, don't click this because this is sample. Don't click this one. Scroll down almost to the bottom, the unadjusted standard deviation, because it has a denominator of n instead of n minus 1. And we compute it, and it comes out to be 3.559. They want it in 3 decimal places, so I'm going to put that 3.559. They love me. Find the standard deviation of each of the 9 samples. I already did it. I even sorted it. I'm way ahead of you guys. So the first one we can see is 0. I'm just looking at the value right there, and then I'm counting it. There's 3 of them out of 9. There are 9 values, 9 possible samples. So 3 out of 9 reduces nicely to 1 out of 3. The next one is 0.707. That's the square root of something important. And how many are there? There are 2 of them, so I'm thinking 2 out of 9. The next value is 4.94. Rounds up to 4.95. And again, there are 2 of those, so 2 out of 9. And the last value, I can see it over there, is 5.657, and there are 2 of those. That was great. And then they say, find the mean of these sample statistics, of the sample standard deviations. And in order to find the mean, these data are arranged in a column. So I go to Stat, I go to Summary Stats, I go to Columns, I choose that column, and I click on standard deviation, and I compute, and it comes out exactly it's not exactly the same, is it? Oh, look, they're different. Whoa, what? They're different. Right. Which ones are the same? Our MVPs, the mean, the variance, the proportion. This isn't the one of those. This is a standard deviation. We don't expect it to come out the same, and it didn't. The mean was actually 2.672 after we round it. 2.67, the mean. I found the standard deviation of the thing. Gary, pay attention. Let's do it again. What do I need to do? I need to go to stat. I need to go to summary stats. These data are in a column. It's standard deviation column. I want the mean of the standard deviations. Still not the same, right? 2.514. It'll like that a lot better. Sorry for hitting the wrong button. It's been that sort of week. So do the standard deviations of the sample target the value of the standard deviation of the population? And you look and you say, no. Yeah, but is it like exactly twice or exactly half, or it's exact? No, they're just like really different numbers. So that makes them biased. They do not target. There you go. Therefore, they are biased. They always come off wrong. That's what bias means in statistics. How many of these do you want to do? We can do as many as you like. This one's the median. This one's not so bad. You're going to do pretty much the same thing, except instead of finding the standard deviation of each row, you'll find the median of each row. I don't think that'll be difficult for you. Once you found that, you can find the population median. You can probably do that in your head. 1, 2, 12. I wonder what the middle value is. 2? Yeah, you did it in your head. And then you find the mean of all of your row medians, and you'll find out that it's different. Yeah, why? Because this is a median, and our most valuable players are the mean, the variance, the proportion. So I'm going to skip that one because I think you can do it. This one is even numbers. This one's harder, so let's do that. So I will open it up in StatCrunch. And you're thinking, even numbers? What do you mean even numbers? Oh, which numbers are even? What's the proportion of even numbers? So for example, here's a 2 and a 2. What proportion are even? Well, they're all even. And how do you say all? So I'm going to put even proportion up here. And you're thinking, use StatCrunch. No, StatCrunch doesn't have a function to find out what proportion are even. So you have to look at it. Well, if they're all, that's 100%. That's 1, right? So you put in a 1. And here, there's 1 even and 1 not. So 1 out of 2, I'm going to put a 0.5. And here's a 2 and a 12. They're both even. That's 100%. That's a 1. 7 and 2, well, 1 out of 2 is even. That's a 0.5. And so on like that. 7 and 7, neither 1. So that's a 0. And this is a 0.5. And this is a 1. And this is a 0.5. And this is a 1. You get the idea. And then what? It would be nice if these were ordered, because then we could count them more easily. So I will sort them ascending. And I'll say there are some that have a proportion of 0. How many of them? Well, 1 out of 9 samples. So 1 out of 9 is my fraction. And then we come to 0.5 as the next possible proportion of evens. And there are 1, 2, 3, 4 of those. So my probability proportion is 4 out of 9. And then here they're all, so 1. And it looks again as though there are 4 of those. So 4 out of 9. Excellent. It's nice to be loved. Okay, what's the proportion of even numbers in the population? Well, it's 2 and 7 and 12. And you think to yourself, 2 and 7 and 12, well, 2 is even and 7 isn't and 12 is. So I'm thinking 2 out of 3. So the proportion of even numbers in the population is 2 out of 3. And if you want, you can use a calculator. It comes out to be 0.666666666, and you round it eventually to 7. But it's 2 out of 3. And then you say, I wonder what the mean of these proportions is. And you go to stat, and you go to summary stats. Those data values are listed in a column. I named it so that I wouldn't get totally confused, and we're finding the mean of the sample proportions. And we get, oh, look at that, 2 out of 3, 0.6666666. The proportion of even numbers is equal to the mean of the sample proportions. Cool. So what does that mean? That means that this was a pretty good predictor. The sample proportions did target, so they do, whoops, not that one. The sample proportions target the proportion of even numbers in the population, so sample proportions do make good estimators of the population proportion. I like to work that one for the students because sometimes they get troubled. How do you know if they're the proportion of evens? Well, you count them. So here are the 4 wealthiest people in a particular country. And how many billions of dollars do they have? Well, this country has a person with $35 billion, and the next richest person has 29 billion and 24 billion and 15 billion. That's a lot of money. And we will get samples of size 2 from this population of the 4 richest. So what do I need? I need to get a brand new StatCrunch window, because this is the one, I mentioned it earlier, where I have to key these values in myself. So go to Question Help and choose StatCrunch. Here comes the StatCrunch window. We will tile it, and then I'll put in my values. And remember, when we worked the first one of this section, problem number 2, I said, notice there's sort of a pattern. And the pattern was each of these values appears how many times? 1, 2, 3, 4 times. And then each value will appear over and over 4 times. So what does that mean? It means I put in 35, that's the first value, 4 times. And so 35, enter, 35, enter, 35, enter, 35, enter. You see how it goes. Do the same thing with 29. So 29, 29, 29, 29. Do it again with 24, 24, 24, 24, 24, and do it with 15, 15, 15, 15, 15. Nice. And then what does this look like? This will have a sequence of these, 35, 29, 24, 15, and then again and again and again. And if you want to cut and paste, you could 35, 29, 24, 15, 35, 29. For me, it's almost just as fast. Of course, I worked my way through college years ago doing 10-key data entry. For a big multinational oil company, I could tell you stories. Anyway, I think I got it. So here are what, 16 different, and you think to yourself, yeah, there were 4 values and there's 2 of these, so 4 squared, that's 16. And if you think back, we used to have populations of 3, and we had 3 squared. They each had 9 possible samples. So here are these samples. And what are they interested in? They want to find the mean of each sample. So it's easy for me to find means of these values in these rows. I go to Stat, I go to Summary Stats. I just mentioned these data are arranged in rows, 1 row for each sample. I choose the 2 values. I want to know the mean. I want to make sure to store it in the data table so that I can manipulate it myself later. So here are the values. It's time to start manipulating. So I use the pull down to sort them in ascending order. And then I look over here and go, dang it, they put them in descending order. Well, that's the work of but just 1 click. Hey, look at that. They're descending. And how many are there? There are 16. And there's 135. So 1 out of 16. And then how many 32s are there? There's 2 of them. 2 out of 16. That reduces to 1 out of 8. And how many 29.5s? And you think, this is kind of busy work. It is kind of busy work. So let's just move through it. I'm counting these things and putting in the fraction 1 out of 16, 1 out of 16. 2 of the 26.5, so 1 out of 8, it reduces. How many 25s are there? 2 of those, so 1 out of 8. How many 24s? There's just 1, so 1 out of 16. How many 22s? 2 out of 16, which reduces to 1 out of 8. 19.5s also reduced to 1 out of 8. There's only 115, and so it's 1 out of 16. Whew. It's not hard. It just takes you a little bit of effort. I seem to have lucked out. Compare the mean of the population to the mean of the sampling distribution. So if you wanted to do this with a calculator or in your head, it involves adding these four numbers up and dividing by 4. I think I'm just tired enough that I'll list my population here in its own column and then use my summary calculator on that column to find the mean. I got 25 3/4 as my population mean. What's the mean of the sample mean? So again, stat, summary stats, columns, the row mean, that's my statistic. I'm finding the mean of the means. This is that sentence I like to say. The mean of the sample means is, yes indeed, the population mean. What's the value? It's 25.75. And it is indeed equal to the mean of the sample means, which is 25.75. And we expected that because MVP, the mean, the variance, and the proportion, are the three unbiased estimators. They do target the population mean, so they do make good estimates because the mean, I just said this, it's unbiased. That's how that works. That one was tricky because we had to key in the values ourselves. This one, they do the work for us. You think, isn't this the same problem? Yeah, it just has a median instead. Okay, I'll let you do that one. I don't think you'll have troubles with it. 58, 44, and 60. Those are three government officials. That's how old they died. I guess it's a stress being a government official. I hope to live longer than this. What? Anyway, assume that 2 of the ages are randomly selected, and you think to yourself, well, if there's 2 of these randomly selected, it's going to be the square, so 3 values squared. There must be 9. I think it's this one then. And you can look through and you can see, oh yeah, I kind of see that pattern. And then if you did list them all in StatCrunch, and you're thinking, wait, list them? Oh, why couldn't they do it for me? No, they're not that nice. I mean, you could copy them. You can't really copy them. You can read them off. You can read them off because you can say, okay, I'm going to key in this stuff, but it's easier to use the pattern, right? I'm looking at 58 and I'm thinking I got to do it 3 times, 44 3 times, 60 3 times, and then cycle through these. So here comes 58, 58, 58. There's 3 times, 44, 44, 44, 60, 60, 60, and then cycle through all of them. So 58, 44, 60. I hit this one wrong, didn't I? Backspace, 58 there. Be more careful, Gary. 58, 44, 60, 58, 44, 60. And that's our pattern, and it matches what we found here. So here they want to know the range of each of these samples. So we go to stat, we go to summary stats. The samples are each in their own row. We want both of these values, and we want to know the range. It's right there. Make sure you store it in the data table so that we can manipulate it further. There are all the different ranges. We sort them up or down. 0. Yeah, let's sort them up. We'll start with 0. And there are 1, 2, 3 zeros. So we identify the 0, and there are 3 out of 9, which reduces to 1 out of 3. Next value is 2. And there are 2 2s, so 2 out of 9. Next value is 14. There are also 2 14s. And the last value we have as a range is 16. And there are 2 out of 9 16s. So far, so good. Anybody want to make a prediction? You can make a prediction because you've known these things. What you know is that the things that do target, the things that do have a mean equivalent to the population are our most valuable players, the MVPs, the mean, the variance, the proportion. This is not a mean, it's not a variance, it's not a proportion, it's a range. I don't think it's going to match then. So you could look at this and say, well, what is the range? 58, 44, 60, lowest to smallest. I think the range is 16. If you want to use a calculator or enter it in StatCrunch, you could. The biggest range you can get is 16. Well, what's the average? What's the mean of these? We go to stats, summary stats. We look at this column of the sample statistics, the row ranges. We find the mean of this, and it comes out nowhere close to 16. So the population is not equal to the mean. It's not the oldest. It's not the youngest. It's just very, very, very different. And we're not surprised at that because we don't expect a range to be a good estimator. It's biased. Sample ranges do not target, therefore they make good. Nope. They do not target, therefore they do not make good estimators. That's right. You could do this in StatCrunch if you liked typing, but there's no need to. So the whole idea is, what's the proportion of girls from 2 births? And if you have 2 births, you might have 2 boys, or a boy and a girl, or a girl and a boy, or a girl and a girl. And you think, well, some of these have no girls at all, so let's put in the no girl. If you have no girls at all, well, that's the BB, and that happened 1 out of the 4 times. And sometimes, well, here BG, you get 1 girl. And how often do you get half of your babies being girls? 1 out of 2. Well, there's 1 with 1 girl, and there's 1 with 1 girl. That's 2 family constellations with 1 girl out of a total of 4 family constellations. So it's 2 out of 4. They want me to simplify here, so I'll put 1 out of 2. And then what's the third possibility? The third possibility is you have 100% girls. So that's a 1, and there's only 1 possibility of that happening out of the 4. And so there's your little table. Do you have a deja vu feeling? I mean, you look at this and you say, wait, this is the same thing that we learned. This is 5-1, 5-2. This is a binomial distribution. This is the number of heads you get if you flip a coin twice. Yep, exactly the same. Hey, I remember that one. It had a mean of 1, right? Yeah, because you multiply these across and add them together. Sorry, it had a mean of 1/2. Had a mean of 1/2, and you say, well, what's the mean of these? And you add them together. 1/4 plus 1/2 plus 1/4. I'm thinking that's 1. Find the mean of these. Anyway, what did we just find? We just said 1/2. Is it an unbiased estimator? We knew it was going to be because MVPs, these are proportions of girls. Proportions, they always work. Well done. A genetics experiment involving fruit flies. So in fact, genetics experiments involving fruit flies have contributed a lot to our understanding of genetics and of statistics. And statistics inform these very, very well. So we have 2 fruit flies. No, we have 2 males. They're named Al and Billy. Isn't this cute? They name their fruit flies. They have little collars with tags on them that say, "Hi, I'm Al. Hi, I'm Billy." No, I don't think they do. And 2 females named Charlene and Dana. You could Google fruit fly experiments and you'll find that there are some really interesting. There's an experiment that's been running for, I want to say 80 or 90 years. It's the same population and their descendants, and they found out all kinds of interesting stuff. about evolution and how it works. Some things very surprising, things that Darwin never knew, things that he was not able to predict. But these fruit fly experiments have been a very rich source of additional data to improve our knowledge of evolution. So what are the possible samples? Oh, I guess I'm going to need StatCrunch. So here comes StatCrunch. So what's going on here? We have Al and Billy and Charlene and Dana. I'm going to use A, B, C, D because it's easier for me, right? And what do we know? If there are 4 possibilities and we want 2 fruit flies randomly selected, then I'm going to have to go 4 times for Al, 4 times for Billy, 4 times for Charlene, 4 times for Dana, 4 times for Al, 4 times for Billy, 4 times for Charlene, 4 times for Dana, and then I need to cycle through them. A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. I want to start dancing the way I was saying that. And then what do I have to do? I have to say the proportion of males. So proportion of males. And I'm thinking the A's and the B's are males. So 1, 1, only a half, only a half, 1, 1, only a half, only a half, only a half, only a half, none are male, none are male. Only a half, none are male, none are male. I think I did that right. So let's put these in order. Going up because they start with 0. So how many zeros are there? 1, 2, 3, 4. So 4 out of 16, that reduces nicely to 1/4. How many halves are there? Well, it looks like there's 8. 8 out of 16, that feels like 1/2. How many ones are there? 4, that feels like 1/4. And you're thinking to yourself, Gary, you just did it again. This is that exact same distribution. We know all about this distribution. We studied it in 5.2. This isn't the number of male fruit flies, the proportion. This is the proportion of heads when you flip a coin twice. Yeah, it turns out to be the same, doesn't it? So what do we know? We know that the mean is 1/2. Why do we know that? Well, because we came over here to stat, we went to summary stats, these data are arranged in a column, we chose that column and we selected the mean and we know it's a half. Yep, it's a half. Good job. How come you put it in ahead of time? Because I know what this mean, this distribution is, this sampling distribution, because we studied it in section 2 of chapter 5 and we know it's 1/2. It was the same as the previous problem. So the sample mean is equal to the population proportion of males. These values are not always equal. No, they're always equal. Let's see. Yes, the sample mean is equal to the population proportion. They're always equal because it's a biased. No. Yes, the sample mean is equal. They're always equal. It's an unbiased. You got to read these carefully, kids. Hello, I can't even say it. Let's do that again. Hello, everyone. Welcome to Math 153, Statistical Reasoning